Hi everybody. I thought I'd make this very short video to tell you about a new course that I'm floating. This is ES410 in your timetable, and it's called Introduction to Inverse Modeling in Physical Sciences. So as you know, physicists have been fascinated with trying to discover the causes from effects, in other words, from observation. So a historical example is when they observed the perturbed trajectory of Uranus, and it would just not add up until they had to add a new planet in the solar system to make the data sensible. So it led to the discovery of a new planet, Neptune, as inferred from the observation of the perturbed trajectory of Uranus. So this is one example of how you can go from observation to the cause. A second example is where the German theoretical physicist Hermann Weyl conjectured that the eigenfrequencies of a drum, the drum that you play, would be related to the area and perimeter of the drum through a particular equation. And this led to one of the earliest examples of a solution to an inverse problem by Weyl, describing the asymptotic behavior of eigenvalues of the so-called Laplace-Beltrami operator. In other words, you could figure out the source, in this case the drum's properties, from the observations, that is the sound it makes. Yet another example is that of the Soviet Armenian physicist Viktor Ambartsumeyan. And he pointed out the apparent analogy between the atom's discrete energy levels. These energy levels come from the Schrodinger equation, solution to the Schrodinger equation, and the eigenvalues of the differential equations. So he then asked the question, given a family of eigenvalues, is it possible to find the form of the equations whose eigenvalues they are? So essentially, this guy was examining the inverse Sturm-Liouville problem. I'll give you a more recent example, or probably something that we are all aware because of medical diagnostics. So you probably know what a computerized tomography or CT scan is. What it does is it combines a series of X-ray images that are taken from different angles around your body, and they are combined using some sort of a computer processing apparently to create a cross-sectional image or slices of the bones and the blood vessels and the soft tissues inside your body, which helps the doctors diagnose any problems that you may be having without actually having to cut open the body. Sounds gross, but basically that is what it is. So this is another example of an inverse problem where you try to figure out the cause, in this case the tissue and the bone structure, from the observations, which is a series of X-ray images. I'll give you one more example. So in geophysics, primarily in say oil and gas exploration, seismic inversion transforms. It transforms seismic reflection data, which is some sort of an observational data, into a quantitative rock property of the rocks that are deep inside the Earth's crust, basically describing how much oil there is or how much gas there is in these reservoirs. And of course, if you make such a discovery using inverse theory, it would be very lucrative for your company if you happen to have an oil and gas company. So as you might have guessed by now, inverse theory is the mathematics, is the art of inferring properties of physical systems from observations. It is the property of calculating the causal factor from a set of observations. I'll leave you with one little thought. So, whenever we do experiments, experimental observations are very noisy. They are sparse. They are inconsistent even. And consequently, the properties we would like to infer can usually not be constrained very uniquely. So inverse theory offers a collection of mathematical methods to address this non-uniqueness. So some of these explicitly require the injection of prior knowledge, which is often not available in a strict mathematical form, but a subjective physical intuition or experience. Moreover, the choice of a specific concept or method is in itself an act of subjectivity, which is unavoidably influenced by practical considerations, including the finiteness of our resources, computational resources, and so on. So this is what this course is about. There are no exams in this course, but all the evaluations will be based on a series of project assignments, and of course I will expect the students to present their work for the final evaluation. So if you have any questions regarding this course, please do write to me, and I hope that this is something that interests you. Thank you very much for your attention.